Good morning all of you. Today we'll find the Ctft of single-sided real exponential function, that is e raised to minus at u of t. Here, because of the presence of u of t, you can change the limit as 0 to infinity. This is your general formula of Ctft, that is x of j omega is equal to minus infinity to plus infinity x of t e raised to minus j omega t dt. And because of this u of t, the limit gets changed to 0 to infinity and e raised to minus at e raised to minus j omega t dt. On integrating, you will get it of the form like this: e raised to minus a plus j omega t by minus a plus j omega. You take the minus sign outside and you apply the limit e raised to minus infinity minus e raised to 0 by minus a plus j omega. E raised to minus infinity is equal to 0 and e raised to 0 is 1. Hence, we get it of the form minus 1 by minus a plus j omega, which will give the value 1 by a plus j omega. Hence, we get the general format of e raised to minus at u of t as 1 by a plus j omega. This is your general form. E raised to minus at u of t, Ctft yields you 1 by a plus j omega. A can be of any value. Now, next step, we'll find out the magnitude and the phase spectrum. Magnitude and phase spectrum, it can be found out by using the formula, that is mod x of omega is equal to root of a square plus b square, where a is the real part and b is the imaginary part. In this case, we have to make it of the form real part and imaginary part. Because it is of the form 1 by a plus j beta, we need of the form a plus j beta. So we multiply and divide by the conjugate a minus j omega in both the numerator as well as the denominator, and we get it of the form a minus j omega by a square plus omega square, because the denominator is of the form a plus b into a minus b, and we just split it. Real part is a by a square plus omega square and the imaginary part is minus j omega by a square plus omega square. So this is your a, that is the real part, and this is your b, that is the imaginary part. So next step, we'll find out the mod x of omega for magnitude spectrum, root of a square plus b square, where a is a by a square plus omega square and b is minus omega by a square plus omega square. On solving, we'll get mod x of omega is a root of a square plus omega square by a square plus omega square whole square, which is equal to root of 1 by a square plus omega square. On applying the root, we'll get its mod x of omega is 1 by root of a square plus omega square. And the next section, we'll find out angle x of omega, which is equal to tan inverse of b by a. Substituting value for this is actually capital B and capital A. Substituting capital A and capital B, we'll get mod x of omega as tan inverse of minus omega by a. So this is your magnitude spectrum data as well as this is your phase spectrum data. So that is what is being summarized, that is x of omega can be expressed as its magnitude as well as the phase part, where magnitude part is 1 by root of a square plus omega square and phase part is minus tan inverse of omega by a, for all omega. The next section, we just give the value of a is equal to 1. Hence, mod x of omega is equal to 1 by root of omega square plus 1, because a is equal to 1. And angle of omega, substituting a is equal to 1, we get minus tan inverse of omega. Okay. Next section, you can find a table where we give value for omega as minus 2, minus 1, 0, 1, 2. This is just some known values of omega that can produce you a definite value for tan inverse of omega, that is angle of omega, angle of x of omega, and we'll just find out mod x of omega by substituting value for omega in this equation as minus 2, minus 1, 0, 1, 2, and we'll get for minus 2. For example, we'll get 1 by root of minus 2 square plus 1, that is 1 by root of 5, which is equal to 0.447. Similar fashion, we'll get for minus 1, 0, 1 and 2. And angle x of omega, that is equal to tan inverse of x of omega. Sorry, tan inverse of omega by a, and tan inverse of omega, tan inverse of minus 1 is minus pi by 4. But our equation is minus tan inverse of omega. Hence, we'll have a negative sign here. That is minus of minus pi by 4 is pi by 4. So, for omega is equal to minus 1. The phase is pi by 4. Similarly, we'll find for 0 as well as 1. For 0, tan inverse of 0 is 0, whose negative value is 0 itself. Tan inverse of 1 is pi by 4, whose negative value is minus pi by 4. So this is a table that you have to construct for finding the values to be plotted for magnitude as well as the phase spectrum. And the next step, we'll plot the magnitude and phase spectrum. That is, for 1, we have got the, for 0, you have got the value 1. Here you can see for 0, you have got the value of magnitude of x of omega as 1. For minus 1, these two are minus 1, it is 0.707, these two cases, and for minus 2 it is 0.447. Okay, and angle x of omega for minus 1 it is pi by 4, and for 1 it is minus pi by 4. So that is how you have plotted. That is, magnitude spectrum is nothing but mode x of omega plotted versus omega, and phase spectrum is nothing but angle x of omega plotted versus omega. So that is how you plot for magnitude and phase spectrum of the exponential function. Hope it's clear to you. Thank you.